Saxon's Calculus, Lesson 97, is about volume by shells. Now, I have started off with the diagram for example 1. I'll get to it. But before that, I am reminding you that although my preferred formula for circumference of a circle is pi times diameter, in this case, we're going to be doing 2 pi radiuses because 2 radiuses is the same as the diameter. And the reason for that is that this radius is going to be substituted in as whatever our equation was that we're dealing with. So then, because we're doing volume, we need to also multiply that area of the circle times the height to get the overall volume. So now when I get to example 1, it says the region bounded by this graph, y equals x minus 1, and the x-axis and x equals 4, which is why this line is drawn here. So we're talking about this area being rotated about the y-axis, so this way. Use the shell method to find the volume of the solid generated. So the shell method is basically telling you that we are going to divide this area into a whole slew of rectangles, just like we have with every other area under a curve we've done. And they show you a picture of what one of these triangles rotated looks like. I can't draw it, it's massively in 3D, but it is there on page 474 to help give you a visual for what it looks like when you rotate it. All right, so as we have done before, we are going to be integrating, and so we know we're going from 1 to 4, and we are filling in with our 2 pi acting as a constant because 2 is a number and pi is a number, and then we have our equation for the y, so that is the x minus 1, so that's acting as the radius, and then we are also using the value of x, because that's the variable we're using, in here before we integrate. Dx should be at the end of that. Okay, so then if we distribute that x out, we end up with x squared minus x that we are integrating. And so that will turn into, of course, 1/3 x cubed minus 1/2 x squared, and we are plugging in from 1 to 4, and of course multiplying in front of all of that is still that 2 pi. Now I'm used to the zeros killing everything off, but in this case they're not. So you're going to calculator it, but 4 cubed, 64 over 3 minus 16 over 2, so minus 8. And then that is subtracting the 1's plugged in, so that's going to be 1/3 minus 1/2. And then again, I could common denominator that or just punch it on the calculator, and I'm just going to use what they have here. And then of course remember to multiply by the 2 pi, and so you end up with 27 pi if you don't multiply out with the pi. And it's units, and because we're dealing with volume, it's units cubed. Oops. Okay, example 2. Use the shell method to find the volume of the solid formed by revolving about the x-axis. Okay, so now it's going to be different, and I guess I should draw that. At least it's a quick one. So that's a 4, that's a 2. The equation is x equals 4 minus y squared. Okay. Revolving about the x-axis, and it's what is in the first quadrant bounded by, in the original they gave you x equals 4 minus, no, that is what I wrote here, 4 minus y squared. Okay, we're good. And the x and y axes, yes. Okay, so we know we're going to integrate, and since we're revolving about the x-axis, it's the 0 to 2. And we will have our 2 pi as our constant in front, and then we will have, and we want the y's in here, so 4 minus y squared going again with the y for the other piece, and then the dy, so distribute that out. So we've got 4y minus y cubed. So then when we integrate, this goes to 1 plus 1 is 2. So 2y squared minus 1/4 y to the 4th, plugging in the 0 to 2, triple checking I don't have any errors so far, we're good to go. And of course, we're still multiplying everything with that 2 pi. And then 0 is going to kill all those off, so we just have the 2's to plug in. 2 squared is 4 times 2 is 8 minus 2 to the 4th. 2 times 2 is 4 times 2 is 8 is 16. Divided by 4 goes back to 4. And then that makes it basically 4 going with the 2 pi. So that is 8 pi units cubed. Example 3, use the shell method to find the volume of the solid formed by revolving about the y-axis. So we're revolving here. A region bounded by the x-axis and the graph of y equals negative x squared plus 2x. Now that's a parabola, and it's honestly however you wish to choose to graph it. So you can plug in the points and then graph those points. I would have to do like a complete the square in this format to get the actual vertex point, which I don't particularly want to do, but I do know that if I plug in 0, I get a 0, straightening that line out a bit, and then, okay, maybe if I plugged in 4? No, that's going to be way too big. 2 squared 4, negative 4 plus 4 gave me 0. Oh, okay. So then I know I have to have a parabola in here, something along that line. Okay, so now we need to be doing our integration. It was revolving about the y, so on our x, it's going to be then 0 to 2, as we found. 2 pi is going to be in front, and we will have our negative x squared plus 2x going with our x. Now distributing would give us negative x cubed plus 2x squared. Integrating would give us negative 1/4 x to the 4th plus 2/3 x cubed, plugging in the 0 to 2 and the 2 pi still multiplying in front. I'm just double checking before I throw in numbers. Okay, zeros are going to throw everything off, so it's just the 2. So that should go back to negative 4 plus 8, 16 over 3. And then on the calculator, I could common denominator that. Yeah, it's fast. All right, so negative 12 plus 16 is, just a second. Yes, common denominator was 12. Should be 4/3. Oh, yes, it is. Yes, 4/3, and then I'm multiplying with the 2 pi, so that is now changing it to 8/3 pi. Now I'm matching units cubed. Last example.